Now we have a question. This question, you see, you have four forces. We have four forces that act as shown below. So you see the forces acting. We have to calculate their resultant. Now all these forces are acting in different directions, and we have to find the resultant. So you know that to find the resultant, we can easily find the resultant of forces that are either parallel to each other, where we add or subtract depending on whether they're going in the same direction, or when they are inclined at 90 degree. So if I have two forces inclined at 90 degree, we can easily find the resultant, because the resultant will be the hypotenuse. Now when we have forces acting in different directions, all we need to do is to resolve all the forces into their horizontal components and vertical components. So I'm just going to divide our space. So I'll divide our space. All right. So we're going to see on the left, we're going to see the summation. Now this is the summation symbol of the forces of the horizontal forces. So we just call it Fx, the forces on the horizontal. Since the horizontal is associated with x, let's use x for it. And then on the other side, we're going to say summation of Fy, which is the forces in the vertical. So we sum all of them, and then after all, we find the resultant. Well, we can start from anywhere, but let's start from 10 and then go anti-clockwise. Now, consider this force, 10 Newton. Consider the 10 Newton force. What is the angle it makes with the horizontal? Please, this is the first thing you should take note of. What is the angle it makes with the horizontal? Well, the angle it makes with the horizontal is 30 degrees. Alright, so resolving it now into the vertical and the horizontal components. First of all, in the horizontal components, you know it's always associated with cosine. Now, another thing you need to know, I forgot to mention, is that we put signs to this thing, right? So this is the positive y-axis, this is the positive x, this is the negative y-axis, and this is the negative x. So you take the sign along. So you see that this 10 Newton is going towards the positive x direction. So we're going to put plus to it. So that will be 10 cos 30 degrees. That's positive 10, but no need of writing it. For the vertical, we are going to have, is also going along the positive y direction. So it's going to be positive again. We have 10 sine 30 degrees. So we are done with that one. So let's move over to the next one, which is 12 Newton. Now, for the horizontal, you see that this 12 Newton is going in the direction of the x and negative x direction. So look at the angle it makes with the horizontal, and look at the one we are working with now. See that it's going towards the negative, so it's going to be negative. So it's going to be plus, let's open a bracket, minus, since it's negative now, 12 cos 40 degrees. All right, plus the next one. So let's do it for the vertical component. You discover that the 12 Newton is also towards the positive y, so it's still positive, plus 12 sine 40 degrees. Now let's move on to the next force. We're done with 10 Newton and 12 Newton. Now we are towards 9 Newton. Now you notice that this 9 Newton is acting straight towards the vertical, so it does not have any horizontal component. It has only vertical components. Well, you can also prove that using what we have been doing before. First of all, you need to ask yourself, what is the angle it makes with the horizontal? So if this is 9 Newton, discover that the angle made with the horizontal is this angle to that horizontal. So if this is 60, this angle here is 30 degrees. 60 plus 30 is 90. So it makes an angle of 90 degree with the horizontal. So you're going to say for the horizontal component is going to be 9 cos 90 degrees. But you already know that cos 90 is 0. So 9 times 0 is 0. So anytime you see that a force is or a vector is acting exactly in one direction, then it does not have any component in the other direction. So let me just put it there so we can see it. The horizontal component is 0, so we're going to put plus 0. Whereas the vertical component is just, is it positive now or negative? You see that it's going towards the negative y, so it's going to be plus, I'll open a bracket, minus 9 Newton and close the bracket. So add another plus. Finally, now we're in the last force, which is 15 Newton. What's the angle 15 Newton makes with the horizontal? 60 degrees. So We're going to ask ourselves again, this 15 Newton, is it going towards the positive x or towards the negative x? It's going towards the positive x. So for the horizontal, it's going to be 15 cos 60 degrees, right? And that will be the last one for the horizontal. Why the last one for the vertical? You see that 15 Newton is going towards the negative because it's going downwards towards the negative y. So we're going to put another minus 15 sine 60 degrees. All right, so that's it. So now let's solve. Let's just simplify. For the vertical, for the horizontal, we have 10 cos 30. But let me just put it down. I have 10 cos 30. Plus minus here is minus. So it's going to be minus 12 cos 40 degrees plus 0. Then plus 15 cos 60 degrees. Alright, so you see that we have, I'm going to approximate to 2 decimals. So you see finally we have our answer as 6.97 to 2 dp and 6.97 Newton. So this is the sum of the horizontal components. Let's sum the y components also. So for the y, this is going to be equal to 10 sine 30 degrees plus 12 sine 40 degrees plus minus here is going to be minus, that will be minus 9 Newton, and then plus minus again here is going to be minus 15 sine 60 degrees minus 9. So at the end of the day we have negative. So our final answer is negative 9.27 to 2 dp now will be 28, all right, 9.28 Newton. So now when we have resolved these forces, we can now go ahead and draw them, put them together since we already know their specific directions. For the horizontal components, we have uh, a positive value. That means it's going in this direction. So we're going to put the positive value. This is the positive side of x. And then for the vertical component, it's going the negative. So it's going to be going downwards. So this is the negative value of y. Then let's put their values. This is 6.97 and this is, use the color there, 9.28 Newton. So now the resultant, I'll use green for the resultant. The resultant is simply in this direction. This direction, this is the resultant. So that's very simple. So what's the angle the resultant makes with the horizontal? Is going to be this angle. So we're going to solve both the magnitude and the angle. So let me highlight the angle. So you just take note, we need to solve that. Let's call it theta. So first of all, let's find the magnitude of the resultant, which is r, right? This resultant is opposite this right angle, so it's the hypotenuse. So using Pythagoras theorem, r squared is 6.97 squared plus 9.28 squared. So r is basically the square root of 6.97 squared plus 9.28 squared. So let's just plug in everything into our calculator and we get the value. So r is the square root of 6.97 squared plus 9.28 squared. So that's what we have. We have r to be equal to 11.60, which is just 11.6, 2 dp. Remember, always working with 2 dp Newton. So this is the magnitude of the resultant. What's the direction? Direction is the angle it makes with the horizontal. So we can use trigonometric ratio to find it. So that angle, let's work with these two sides. So I'm just going to work with these two sides, this side and this side. So remember, 9.28 is opposite, so opposite, and 6.97 is adjacent. So we're going to work with tan. So we're going to say that tan theta is equal to opposite over adjacent. Opposite is 9.28, adjacent is 6.97. So theta is going to be the tan inverse or the arctan of 9.28 over 6.97. So let's go ahead and plug it into the calculator. So we have the arctan of 9.28 divided by 6.97. So when we do that, we have 53.09. We have 53.09 again to 2 degrees. So this is the angle it makes with the horizontal. But if you want to represent it with a compass bearing, you just have to subtract that angle from 90. So we're going to do 90 minus 53.09, which will give us 36.91. So you see that this resultant is going downwards. All right. So it's going downwards. So this will be the southeast direction, because this side is the east, downwards is the south. So the resultant is going southeast. So we're going to say this is south, that's 6.91 degrees east. So I'll put my degrees there.